emission during fusion-based processes. So Dr. Aslam has published several research papers with high impact journals and conference also. He has contributed as a reviewer for different peer-reviewed journals and participated in technical events like workshop or academia outreach activities. So his aim is to bridge the gap between the fundamental research and the industrial applications. So with this, may I request Dr. Aslam to start his presentation.
Thank you, sir, for the introducing me. So now I'm opening my PPT. So I will start. Sir.
Yes, yes.
Hmm. So my PPT is visual, sir.
Mm, no, sir, I cannot see. Any participants, can you see the presentation? No.
Yes, PPT is visible.
Sir, visible.
Yeah,
visible.
Yes, sir,
yeah,
visible.
visible.
But I cannot see your PPT. Okay.
Okay.
Maybe there is problem from
Thank
my
you
side. Yes,
for
yes.
the. So now I can
Yes, yes,
start.
please. You
So
can start your presentation.
here I will talk about the advanced. Uh, okay. Okay, sir. Thank you, sir. I will continue. Okay, thank you. Today I will discuss about advancement in additive manufacturing. Okay, sir. Thank you, sir. So here, first of all, additive manufacturing. So prior to discuss additive manufacturing, we will discuss a little bit about the some building processes. Like now, current days, we are using some different name like welding, cladding, coating, additive manufacturing is related as like metal additive manufacturing, and so many, just like metal additive manufacturing, polymer additive manufacturing, after the laser additive manufacturing, powder bed fusion, so many methods are there. But what are the basic differences between welding, coating, cladding? So welding is just nothing as a join of two pieces applying heat or pressure. That's it. After that, what is the coating? Just if we develop any layers on any substrate up to a 50 micron by any means, just like if you are using PVD method, CVD method, like a welding process, like a TIG welding process, when we develop a layer up to a 50 micron, as per the which I have reviewed minimum research papers. So up to 15 pattern we can consider as a coating process. It will depends upon the processing and conditions.
Sir has left, sir.
Yes, sir. Maybe some issue there. Please wait for 1 minute. Maybe you will join.
Sorry for the inconvenience. Just I'm sharing my PPT. Okay. Uh, this is the basic introduction of the additive manufacturing process. So now and next, what are the advancement in additive manufacturing? So the first 3D printer fabricated in 19 near about the 1980 by Dr. Hido Kodama. After that, slowly advancement grew up, and now with the nowadays with the help of 3D printer, we have fabricated just like aircraft components, as well as just like a 3D printed houses and clothing experiment by the NASA. So different things where we have fabricated. Now in the recent scenario in IIT Indore, we have developed a micro laser based 3D printer which we have which fabricate metal based things with less cost. So this is the basic flow in advancement in additive manufacturing. So it will started from 1980, and nowadays various type of additive manufacturing process are available. So after that, one other technique in India also developed just like a agricultural compass for the designing and fabrication of the rocket components. So these are the two recent advancement in India, like one IIT Indore, just like a microplasma metal additive manufacturing for the fabricating of metal-based component. After that, one agricultural campus. This is also developed in India, just like the fabrication of the rocket components. And also, okay, now we have discussed a little bit what is the various type of additive manufacturing process. So now I am working in wire car additive manufacturing based. So here I am discussing a different type of additive manufacturing process. So here in biomedical sector, just like lithography and other things, just like digital light processing and continuous liquid. So different types of additive manufacturing are there in the just using a white photopolymerization, material extrusion, material jetting and binder jetting, powder bed fusion, and directed energy fusion, directed energy deposition, and a sheet metal laminated. And here also we have just metal additive manufacturing process also using different type of technique, just like a directed energy deposition system, powder bed fusion method, and sheet laminated. And these are the things which using these techniques we can fabricate a different types of geometrical shape of object. And after that, what are the importance of the additive manufacturing things? So here, easily we can understand with the help of figure. Okay, additive manufacturing used in various fields, just like a tissue engineering in biomedical sector. After that, automobile, aerospace industry, pharmaceutical. After that, architectural design and biomedical applications. So what are the basic latest trend in additive manufacturing? Just like a novel material and multi-material, 4D printing, and micro manufacturing, control and monitoring, process optimization, novel techniques, post processing, data acquisition, sustainability, and also nowadays we are using different machine learning things for the improving of the quality of the fabrication part with the help of 3D printer or additive manufacturing techniques. And additive manufacturing, for the fabrication of the any component, we can use just like a laser-based additive manufacturing, electron beam-based additive manufacturing. After that, wire car additive manufacturing. So different type of additive manufacturing are available. So this is the basic methodology how we can execute from raw material to our component. So first of determine the object. After that, create the design and just generate the code. And after that, transfer the file for the print. And after the printing, just remove the excess material which is undesired for the component. After that, just after this is the final product. Just remove the unwanted material and we will get a finished parts. And various type of metal additive manufacturing process are available, just like a powder-based, wire-based, and other, just like ultrasonic consolidation and friction freedom. So what is the powder-based? Powder-based is so many MMC powders are available, just like a titanium carbide, silicon carbide, tungsten carbide, and silicon nitride. So many different types of MMC powders are available. So with the help, as per the requirement of the component, we are using different types of powders. And also nowadays we are using different types of biometallic components to get the desired properties of the material. We can proceed according to that. And here in with the metallurgy manufacturing, so we can here categorize in powder based, wire based, and other. Just like in case of powder based, there just you can see here laser based, electron based, and electron based. These two three methods we are using for the powder based. And here for the wire based, so arc based deposition, electron beam, laser beam also used for the wire based also. And in case of what is the arc based? Arc based is basically just create a arc using any means. So to melt the material and deposit to them. So this is the arc based. Just like for the example, TIG welding, gas metal arc welding, laser welding, and electron beam building. So these are the example, and with the help of these things, we can melt the electrode wires and wires and just deposit on it, and layer by layer things. Just we can say this is the part of additive manufacturing. So another one, this is the metal. Again, we can classify it into two types: fusion based and solid based. So here we have fusion based. I will further characterize into two parts, just like indirect energy deposition and directed energy deposition. So the for the directed energy deposition, just we can for the example gas metal arc welding, and indirect deposition is powder bed fusion method. So here just with the help of figure, easily we can understand how it will work. So in case of here, two to three things are there, and electron beam based and laser beam. And laser beam, in case of directed energy deposition, laser beam, wire arc, and electron beam. And here solid state, just like a additive stir deposition, just like a friction stir welding. So what are the application of additive manufacturing in industry? So nowadays, a lot of applications are there, just like we are using additive manufacturing techniques in biomedical sectors and aerospace sector and marine industry, and just like here architecture, academic institution, military, medical, and here also just like industrial machines, and lot of automotive parts are there, which we can fabricate with the help of additive manufacturing techniques. So here major concern is that maximum utilization of additive manufacturing sector according to industrial adoption of additive manufacturing, industrial machine, and after that aerospace industry. So these two industry in industrial adoption in of the additive manufacturing we are using frequently. So after that application of the metal additive manufacturing also used in just like a material extrusion, wet photopolymerization and lamination, and also here we can use for the material and binder jetting. And here just thing is that powder bed fusion method frequently used for the additive manufacturing techniques. So nowadays up to 2024 it was using frequently. Nowadays powder bed fusion method and wire arc additive manufacturing more recent advancement for the fabrication of the any metallic component in three geometrical shape of object. So, by various things are there, just like we can, with the help of additive manufacturing techniques, we can we can repair with the help of additive manufacturing techniques. We can repair the component also, just like a crack in plane, corroded parts of aircraft, turbines of broken turbines and ships, and corroded part of aircraft and crack in plane. So with the help of additive manufacturing process, we can repair it. And also as per the desired properties, we can use a bimetallic component and we can fabricate it. After that, as previous I discussed, powder bed fusion method frequently used nowadays for the fabrication of the metal based, ceramic based, polymer based component. in industry. So this is the working principle of the powder bed fusion method. A laser beam strike on the glass, and after the strike on the surface, as with the help of as per the depends upon the CAD model, it will fabricate the components. So powder bed fusion method, we can fabricate just like a metal based, ceramic based, and polymer based. After that, here I am also discussing what is the process. Just previous I discussed electron powder bed fusion and laser powder bed fusion and laser directed deposition, which we are using frequently. So here it is showing like that. Just first one like a electron powder bed fusion, and second one laser powder bed fusion, last one laser directed energy deposition. So what are the things are there? Just like in case of electron powder bed fusion method, so here we can observe that uh, just like a grain growth, like toward the substrate is just like a grain growth size is more. After that, in case of laser powder bed fusion method, the grain size of the grain size in the fabricated part is smaller. But in case of the latest directed energy deposition system, the mix up and also in this case the preparation of the preparation in substrate material is higher. And also we have observed that in case of wire arc additive manufacturing, the grain growth, grain size is more as compared to this one, because uh, laser and electron beam welding is good. But in case of arc additive manufacturing process, just yeah, definitely we can fabricate different types of metallic component with the help of arc additive manufacturing process. But problem is that if you want to fabricate a high quality of the product, we can choose the powdered bed fusion method and other things. And if you are we want to fabricate a high deposition rate, but high deposition things, just like if you are repairing a shaft and turbines like that. So here we the utilization of the electrode wires are more, so we can use wire additive manufacturing process. So here easily we can see electron powder bed fusion, a smaller grain size and well settled. And in case of laser powder bed fusion method, easily we can see lesser as compared to electron beam. And after that, in case of laser directed energy deposition process, mix up. So this is the publication trend now up to 2023. So wire additive manufacturing process and laser powdered bed fusion method publications are more as compared to other. So nowadays, in the current scenario, wire additive manufacturing and laser powder bed fusion method most frequently used in China, and after that Germany, then Poland, and so on. So the now in the additive manufacturing process highly used in wire additive manufacturing and laser powder bed fusion method. So here also I'm showing here some application how to repair. So here we can repair a soft and also turbine blades and also hull, ship hull. After that, here lastly we are showing that how we can convert failure component into a final product with the help of additive manufacturing techniques. So this is the previously I discussed some thing, and now we can discuss what are the failure in metal additive manufacturing process. As we have seen in figures, so here we have seen when we are using the silicon carbide in a maximum percentage in any metallic component. So due to the higher percentage of silicon, it will develop a silicon silicide in the microstructure. That's why silicon silicide is less. It is not form a proper metallic bonding formation with the materials. So it will develop cracks during the hardness test. Also, we have observed porosity. Porosity how and when developed? When directly we develop a silica, any MMC powder on any metallic surface, then we have observed that it was producing porosity, micro holes as well as macro holes also. Just for example, silicon carbide when developed on any mildly substrate, so it will develop a porosity as well as micro holes. So we can develop easily. So how we can develop? First of all, we use any good additive material with the help of using MNC powder. Easily we can develop a metallic component with the help of additive manufacturing process. Also, in case of just like a premature failure, when we are using a higher percentage of any MC powder in any component, so it is producing a premature failure. So also we have observed that when we develop a one hard material, one soft material, then easily we can understand it will not weld it properly, and the dilution in the central zone is maximum, and beyond this, at the end of the welding sample, and so easily we can see less. So here, but if we develop a different metallic just like a one thermal conductivity is too high is a large difference in thermal conductivity, so it will produce a incomplete fusion. Highest difference in thermal conductivity as well as highest difference in temperature, so definitely it will develop a incomplete fusion at a interface. So also optimization of the parameter also important, because when optimization of parameter is good, then it will develop a good quality of weld bead. Also, when the process parameter is poor, then it will develop a non-uniform weld bead, and it will at that time it will produce spatter also. So here are some of the figure I have mentioned, just like a geometry related defects, just like parts distortion and parts delimation. After that, start case effects also showing just like a surface integrity related, and here partially melted powder. Uh, just like here, just we can easily see partially melted powder produce just like a premature failure types, and also surface cracking is there, and if balling effect in just like a small electrode is better stick or near the bead. So also here some hard cracking also observed in micro structural defects, and also in the solid state cracking, as well as long induced porosity also observed in laser based additive manufacturing. So here are some of the failure and how we can improve it, how we can repair it. So some of the component I am showing here. So first of all, here we are talking about engine block. So here in the engine block we are using titanium and aluminum. Both are dissimilar metal. As per the requirement of the material, we can just like if the failure towards the titanium side, definitely just use a titanium. And after if the failure towards the aluminum, then easily we can repair it with the help of aluminum in a in engine block. After that, one shaft is there. We are showing here one shaft and failure in shaft. After that, how we can repair with the help of wire carg additive manufacturing process, we can repair the components. After that, failure in gear also I am showing here, and how we can repair it with the help of laser additive manufacturing. We can improve the we can regain its original shape, and with the help of, and also here with the turbine blade also I am showing with the help of laser additive manufacturing process, we can sometimes what will happen, the diameter of the shaft will reduce. So that time, to maintain the diameter of the shaft, to deposit the materials, metals on a surface with the help of different additive manufacturing process, just like a laser-based additive manufacturing, wire arc additive manufacturing, powder-based metal additive manufacturing. So different types of additive manufacturing techniques are there. So we can use it for the repairing of the component. So here after that, in the lastly, I am showing failure in aero engine fan blades. So we can repair with the help of laser additive manufacturing as well as wire additive manufacturing process. So here, what are the part repairing issues in additive manufacturing? So different types of part additive issues are there. Just like in case of metallurgical, so element dilution and mixing, and brittle intermetallic compound, and also solidification cracking and segregation. And in mechanical and structural analysis, we have observed residual stress, distortion, delimation, weak bonding, micro hardness variation, fatigue, and mismatch. And what are the thermal issues? So coefficient of thermal expansion mismatch, difference heat absorption, and remelting of the base alloy. After that, what are the processes? Porosities, lack of the fusion defects, poor wettability, oxidation, and continuation, process parameter optimization, and porosity, and lack of the defects. In case of service performance, what are the issues? Just like porosity, lack of fusion defects, poor wettability, oxidation, and containment, process parameter optimizations. So with the help here in case of additive manufacturing, if we're talking about dielectric energy deposition, just for example, gas metal arc welding. So this is example of dielectric energy deposition process in additive manufacturing. So what types of feed we can feed? So in case of additive manufacturing, so wire based are powder based as well as powder and wire based. These are things we can use for the feed. It may be wire, it may be powder, it may be both. So what are the advantages? So reduce the material waste. What are the importance of additive manufacturing technology? So reduce the material wastage, high deposition rate, low initial cost, and average we can use and nowadays the different hybrid modes are in the process in the material they are using. Just like example, myself I have developed silicon carbide interlayer cladding with the help of steel. Just like example AIS 304. So here we can see what are the parameters. Just this is the example of we can say hybrid mode of the material, and hybrid mode of the machines also available. Just like some of the time we are using TIG and MIG, some of the time we are using laser and MIG, laser and TIG. So different types of commission they are using. Sometimes CMT types in additive manufacturing they are also using. So different types hybrid mode in process and hybrid mode in material also using. And also in case of sometimes we are using powder with wire feed rate. So here what are the parameters in additive manufacturing process? Just like a wire additive manufacturing process. So wire feed rate, fixing of substrate, R gap, travel speed, gas flow rate, tensile. Okay, these are the things we can consider parameter during the additive manufacturing with the help of just say for example wire additive manufacturing. So what are the metal additive manufacturing process? Just like a gas metal arc welding process, get tungsten, just like TIG welding, we can say gas tungsten arc welding, and plasma arc welding, and CMT based and laser based. And what are the allying element we can use for the development different uh, to develop desirable different properties. So we can use titanium, aluminum, steel, magnesium, copper, inconel, invar, and just like embracing steel also. So to get the different desired properties as per the requirement, we can use different types of allying element. Just for the example, if we are fabricating any component to for the strength to weight ratio, so definitely we can use a aluminum material. And just for the example, when we want to increase the hardness as well as wear resistance and corrosion resistance, definitely we can develop a steel material and some MMC with the help of MMC and steel material. So we can develop and we just improve the hardness also. After that, what are the limitation in dielectric energy based additive manufacturing? So controlling heat input, precise layering, minimal residual stress, distortion, accuracy, post-processing, anisotropy, and sizable heat-affected zone. And some of the time, grain growth is also non-uniform during the work or additive manufacturing process. Now, recently, the maximum number of people they are developing a machine learning based things. So how we can monitor the how we can just maintain the grain growth during the additive manufacturing process. And here some of the typical wire feed rate and powder feed techniques also mentioned here, just like a direct wire feed rate, replaced wire, metal met, sorry, MMC powders, just like metal matrix composites, and powder feed, powder plus wire feed, flux core wire. Flux core wire quite better, but this is the costly material. Meanwhile, we can use go for the different other low costs like steel and mild steel electrode. So sometimes we can use MMC plus wire. That's why I'm writing here hybrid. So some of the other conventional alloying, just like in the current scenario, we are using some functionally graded material. So here we are using to get the desired property directly use the that's material for the to get the same output. So that's why we are using different types of functionally graded material just nowadays. So recent advancement in additive manufacturing. So now in the current scenario, we have seen in a different review. So we have observed that biometric and holographic printing is faster printing with better resolution. Also, previously I discussed in the IIT Indore recently developed micro plasma metal additive manufacturing. So it is producing high quality metal parts just for the titanium and super alloy with low cost and less energy, fewer harmful emission, and faster build times. Also, we are implementing in additive manufacturing just like AI monitoring and quality control and hybrid things also. Hybrid means just nothing. If we are using two different materials, different just like powders and metal wires, this is the hybrid. And we are talking about the process, just like a TIG and MIG, if we are using TIG and MIG, this is the also hybrid. If you are using other things, so this is the types of hybrid. So hybrid manufacturing, and after that, construction and infrastructure scaling printing. So these are the things which have recent advancement in additive manufacturing process. And after that, what are the future research in additive manufacturing process? So if we are talking about the materials, so nowadays bimetallic, different bimetallic components. Bimetallic means just nothing, just like two different material, two or more material we can develop on any surface, just like if one layer silicon, another layer aluminum, another layer others. So this is the type of bimetallic and functionally graded material. Also, we can functionally graded material means just like just for the example, if we would if we want to just like if you are aiming to hardness, so similar type material we can use. If you want to wear resistance material, we can use. So as per the desired of the things, we can use a different types of material. So after that, in case of the 4D printing, and in the this is also future research in additive manufacturing, and also AI integration for the optimization, hybrid system, interlayer cladding simulation with MMC. This is also new. Recently, I in the research papers, I've never seen this type of simulation in anyways, just like a laser based, electron beam based, or a wire guide additive manufacturing based. So in this case, we have not seen nowadays interlayer cladding simulation with MMC. So now we are discussing about some research part related to my work. So easily we can understand how wire additive manufacturing, what are the advantage, what are the disadvantage, how we can solve it. So here just I'm here giving the one example how I got it my problems and how I resolved it. So here I'm discussing about here first of all I was developed mild steel or the mild steel material with the help of wire additive manufacturing techniques. So it was developed properly, and now easily we can see in the central portion dilution will be more, but as compared to central portion the dilution will be minimal. sometime at the cladding interface, there is no bonding between two materials. So that's why I found the problem incomplete fusion end of the clad build. So after that, this is the problems I found previously. After that, I this is the grain growth in my mild steel cladding or cladding. Just nothing. Just we have developed any cladding layer more than 1 mm. Yeah, one more than 0.5 50 micron. So this is the process comes under cladding. So here I am showing one image. So both are mild steel, but here if you are seeing at the same scaling 1000. So in the cladding portion, the size of the grain growth is lesser, and in the substrate region, grain growth size and microstructural size will be little bit higher. So we can say grain growth non-uniform in case of cladding layer as compared to substrate. So here easily we can see freight and structure and parallel structure. So this is the mild steel cladded over the mild steel material, and here we have found incomplete fusion. So after that, and even one problem also found, the mild steel is a very it is in various field like different areas we are using mild steel and easily available also. But problem is that it very less corrosion resistance, poor corrosion resistance, poor wear resistance, and hardness is also low. So some of the time the hard material is required for the sustainability in the environment, in the open environment. So after that, we have used a steel material just like a 304 on a mild steel. So easily we can see dilution at the cladding interface is minimal as compared to mild steel. Why? Because in case of mild steel, when I will develop a mild steel clad layer on the mild steel, the both are the thermal conductivity are same, as well as the temperature melting point is also same. So it was not creating much more disturbance in arc generation, and it was melted properly, and dilution was more. But in this case, the mild steel thermal conductivity is different and steel thermal conductivity is different. So that's why at the same welding voltage, and even also the melting point of the steel is higher as compared to mild steel. So it was develop a lesser dilution in the central portion. At the end of the cladding, we also observe that sometimes it's a very minimal metallurgical bonding formation at the cladding interface. So problem is that two problems I found. One is incomplete fusion, other the cladding interface in mild steel. Now I faces another problem. To develop a layer on a mild steel surface, it was creating an incomplete fusion as well as less dilution. So how we can resolve it at the same parameter? So further, we have also seen here some of the incomplete fusion in the first one, and here some material is also here. So here just like a iron percentage in case of EDS analysis, the iron percentage is more as compared to yeah, iron percentage is higher is in case of substrate region like the mild steel as compared to this one. So my purpose why I am showing this one, because I want to identify the clear reason of the things. So after that, what are the microstructure problems? So here in the less voltage, we have observed that grain growth size is more because sometimes solid very less dilution time, and so here as grain growth size is more as compared to higher voltage, because when melted at higher temperature, it will proper to take time to regain this microstructure in proper manner. So that's why at a less voltage we have found a higher grain growth, and of course columnar dendrite structure in the cladded region. After that, we have seen in case of just like we have taken a multi-layer video on a multi substrate. Then I was observed that sometimes it will dilution will be higher and sometimes lower. So further, I investigate these things. I resolve further. So after the discussing this one, so when I check the with the help of corrosion, conducted some corrosion test. So I observed that in case of mild steel sample, it was developed cracks and some dimple types of microstructure. But in case of stainless steel, just like 304, it was developed intergranular types of defects and pitting corrosion and metallic fiber. So in case of mild steel, the corrosion rate is higher as compared to stainless steel. And here, due to the presence of chromium and nickel, it was produced intergranular type of things, which we prevent the corrosion resistance from the corrosion. And after that, easily some corrosion test analysis sample here is there. In case of mild steel, easily corroded 100% parts. And but at the cladding interface, we observed that in the second sample, we have cladded here mild steel to another stainless steel. So in case of mild steel is a 100% corroded material. And but in case of steel, with less material corroded. And here at the corner, some parts corroded. But due to the high current density passes through the contact area, so that's why it was corroded more as compared to other steel parts. So here I was tested some corrosion. I was tested some corrosion test. So here I was observed that the corrosion rate is lesser in case of mild steel as compared to others. So also in case of height losses in case of mild steel is higher as compared to steel. So that was the problem I have found. First one, incomplete fusion. Otherwise, at the cladding, end of the cladding with incomplete fusion. And in case of steel, less dilution. So that problem I solved with the help of MMC powder. So I used silicon carbide. So first of all, I replaced the silicon carbide on a mild steel material. And after that, we are using the wire guard additive manufacturing techniques, gamma-based wire guard additive manufacturing techniques. So in this case, we are using AI 304 stainless steel electrode. So it was developed a cladding layer on a substrate. So after that, easily you can see it is showing clear less dilution. Yeah, this is less dilution, but it was developed end to end into in dilation and proper metallurgical bonding formation. So that's why the problem, the incomplete fusion problem solved as compared to previous one that was lesser wear resistance and corrosion resistance. Now we are using silicon carbide. Silicon carbide is so hard as compared to steel. So here hardness improve, corrosion resistance improve, as well as wear resistance improve. And now some power fluctuation are also there in case of different wire feed. To here I am using two different wire feed rate. So 5 meter per minute and 6 meter per minute. So easily we can observe that in case of a lower feed rate, the temperature power input was more. So when power input more, that's when definitely the melt temperature will higher. And also, okay, now in the cladded parts with the help of silicon carbide with steel, so easily we can see uniformity is also there, not much more element distribution failure. So it was diluted properly, silicon carbide diluted properly with the help of steel. So that's why we can say steel is a good additive with steel, but in limited quantity, not a higher percentage of the silicon carbide. So higher amount of silicon carbide, it will produce silicide, and that's why it will cause of the premature failure. After that, easily we can see in case of silicon carbide is a high temperature stability material in case during the additive manufacturing process. So that's why I am using, because silicon carbide is high temperature stability material at high temperature. So it will give the proper time to melt the material which we can directly contact to the material during the melting. So easily we can see higher dilution also observed in multi-bead layers. And in case of adjacent bead, we have observed that uh, there is complete dilution, and easily we can find the defect-free adjustment. So here some of the weaker hardness is also conducted, but here we have observed that the cause of red color is showing uh, 6 meter per minute over period, and upper one black one is showing 5 meter per minute. The problem is that what is the problem in case of silicon carbide? When we are using the maximum percentage of just like more than 3%, 4%, 5% in with the steel matrix on a mild steel. So it was developed cracks when we conduct a hardness test. Easily it will develop a cracks during the hardness test. Aids of the indentation. So and also when it will diameter of the uh, uh, indentation will be more. That time hardness will reduce, because easily we can say in the red color the hardness near about less than 300. So this is the cause of maximum amount of silicon carbide. Also, in case of silicon carbide FMC with the help of steel on the mild steel, so it was of the chromium carbide and some iron carbide, which the kind to improve the hardness wear resistance. So here I have conducted some wear analysis. So with the help of our car editing manufacturing technique. So here we have observed that easily we have observed that in case of mild steel, the wear rate is higher. So as compared to steel also, and silicon carbide and MMC, silicon carbide and steel is steel MMC. So easily we can understand with the help of my steel improved the wear resistance, corrosion resistance, along with the hardness also. But in case of if we are using the silicon carbide with steel, so it was developed more wear resistance as compared to steel. So here also we have conducted two type of tests. First one with the help of emery paper, another one without emery paper on the EM31 steel during the cleaning, and diameter was that time diameter was 21 mm. So it was observed as negative wear produces during the directly when in case of pin and disc when you are using a directly EN31 steel and test the sample. Then it was observed that negative wear. Negative wear sometimes it will more harder as compared to EN31 steel. That's why it is showing negative, and mild steel higher, definitely higher, less wear, poor wear resistance. So here I observed that because I was using silicon carbide emery paper. After that I tested wear test. So that way some loose particle of silicon carbide stick on the substrate, and same time I tested the EDS analysis. So now easily we can see this is the loose particle of the silicon carbide, and also we have is observed that uniform silicon carbide distribution in the steel matrix with the help of steel. So after that, in the final conclusion, we observe that when we are using mild steel on the mild steel, then dilution will be more. That is okay. But in of the cladding portion, the dilution will be minimum. So less metallurgical bonding formation occur. So improving the things just like wear resistance, corrosion resistance, as well as hardness. So it was using stainless steel and developed. And now in the second case, at same parameter, we observe that dilution decreases as compared to mild steel. But here also we have observed that incomplete fusion away from the central melt pool, center of the melt pool. So, but in case of in the last the third one, this is the first one mild steel cladded on the mild steel. Second one in B figure B, steel is cladding on the mild steel. Third one silicon carbide cladded with the help of steel on the mild steel. So in the last one, we have observed that end-to-end melt pool dilution. So that's why I am calculated here. I have conducted for I found the problem just like a less dilution. So here I resolved the dilution also at the end of the portion, as well as how we can improve the wear resistance, corrosion resistance easily when it dilution will be more. Then I tested as previously I discussed corrosion resistance more, wear resistance more, as well as dilution will be more. Dilution, maximum dilution not a matter, but dilution from end to end matter. So he is found end to end dilution also. So successfully I initiated the one problem I and solve it. Thank you. If anyone ask any question, please ask. If anyone ask any question, please ask. Hello.
Thank you, Dr. Aslam.
Yes,
Can you
yes,
hear
sir.
me? My
Yes,
voice
yes,
is
yes, yes.
audible?
Yes, yes. Audible, audible, sir. Audible, audible.
Yes. Thank you very much, Dr. Aslam, for giving insightful and enriching session. So now, participants, if you have any question, you can you can directly ask to Dr. Aslam.
Yes, please ask.
Those are working related to welding or additive manufacturing.
Yes, yes, sir. Those who are yes, yes, those who are working in wire car additive manufacturing, biometallics, and what are the problem they are facing, we can ask it.
Yes.
And additive manufacturing process also no problem.
Or else you can put message in the chat box. Any query from participant side? This was very wonderful session. We have talked about a different aspect of welding. If you're not, then thank you once again, Dr. Aslam,
Thank you, sir.
for giving
Thank you, sir.
This wonderful session. So on behalf of our organizing committee and from all participants, we extend our sincere gratitude for sharing your expertise and experience with us. So we are sure that knowledge we gain today, it will help for participants also in their future. So thank you once again, Dr. Aslam.
Thank you, sir. Thank you, sir.
Dear participants, we have another session from Dr. Brahmam. So we'll going to start shortly. So I'll share that feedback link for this second session. All of you can fill that one. After that, we can start that next session.
Okay, sir. Thank you. Thank you, sir.
Thank you, Dr. Aslam.
Okay, sir. Thank you, sir.
Thank you very much. Yes.
Thank you.
So participants, you can fill that session to today feedback. After that, we'll start next session. Already Tara has joined.
Good evening, sir. What about the assessment test? Is today or tomorrow?
Yes, yes, Satyan.
What about the assessment test? It will be today or tomorrow, 10 a.m.
Yes, as I told yesterday, so tomorrow we have that assessment at 10 o'clock. It will start from 10 o'clock in the morning.
Yeah.
So it
Okay.
will up to 11 o'clock. So that we will
Yeah.
discuss after this validation. I'll announce what is once it is.
Yes. Oh, thank you.
Okay. So once again, welcome everyone. Good evening to all. So it's our pleasure. We have uh, Dr. B. Brahmam sir. Uh, Brahmam sir, shall we start, sir? Brahmam sir, shall we start now or sir?
Yeah, I'm okay.
Okay, sir.
Yeah.
So then it will go.
If you don't have anything, I am ready.
Okay, sir. Thank you, sir. We can start, sir. Yes, sir. Let me introduce, sir. Then after that, we can start. So it's our honor. We have our distinguished speaker for this session, Dr. K. Veera Brahmam. He is now scientist AF at Advanced System Laboratory (ASL), which is a part of all of you know DRDO, Defense Research Organization, located here in Kanchanbang, Hyderabad. So he had done his postgraduate in physics and PhD from Sri Venkateswara University, Tirupati. His earlier work involved polymers used for missile technology or related advanced technology. So with this, I request Brahmam sir to start your session.
Yeah. నేను వెళ్ళాను మీరు ఓకే అంటే చూస్తానండి Dr. Ashit,
Yes, sir. Yes, sir.
I think screen sharing permission you have to give. Yeah. Yeah, because what is happening is it is not giving permission to open the file. You have to issue the permission on my name. No, it is not opening because permission presentation is required. No, it is asking here some permission to be given by the host.
Asit sir,
Sir, Ramesh, sir.
Yeah.
sir, Asit sir came with Bhavani name.
Bhavani Raj.
Okay.
Screen name is Bhavani.
Yeah.
I'm searching.
Yeah.
Okay, sir. Yes, sir. I am made you as a co-host. I think it will work now.
Sir, your screen is
Yeah.
visible, sir.
Yeah. Now it is open. Not a problem. I think the screen is visible and it is audible.
Yes, sir. Yes, sir.
Yeah, thank you very much. And Dr. Ashit, I am very thankful for you for giving one opportunity to say something about the product realization, basically. Maybe all the team who are here may be connected to material science, design, product, process optimization and all the things. This is just, I want to give how we can start a design, development, realization of some product, especially, which is I'm not talking about mechanical engineering connected thing. I'm talking about how product you can able to design, develop, and realize. Finally, you can able to send it into market. So you know very well. This is my talk as per the introduction. I'm giving how to design, develop a biodegradable bag as a product. Being a mechanical engineer, how we can make this. This is my sequence of presentation where we can go introduction. What is the need, how we have to select the materials, how to identify the process, how we have to do the testing, what way you have to give the technology transfer, and all the things I will cover in a short and brief. You may be knowing that anything coming from the earth, if it does not go back to earth, means definitely there is some problem. So if you take a human also, once he dies, he will go again into dissolve into soil. So hence, it is very, very important that whatever the design we are going to do, it should be sustainable and it should be eco-friendly. And nowadays, you know very well, single-use plastics. Example, you know, water bottles, carry bags, straws, bottles. All these things, one time we'll use it and we'll throw it out. That too, these are all petrochemical-based materials. So, which cannot degrade easily. It will take years of duration to break into microparticles. If you see the impact of plastic on the humans as well as on the environment, in the every plastic takes minimum 200 to 400 years life to degrade into microparticles. That too, there is no collection, segregation, and recycling process in our country. Not only in our country, all countries are facing this problem. And reproducibility and recyclability is less than 1%, 2% only we are seeing. With this, what is happening is lot of impact on land, ocean, animals, ecosystem, it is spoiling. Because of that, you know, the cows and all animals, they are by eating these polythene carry bags and all the things, they are dying. That made me to start some innovation for making a alternate solution for the polythene carry bags especially. If you see the plastic waste management rules says that first we are throwing the plastic products, we have to collect it, we have to segregate it, and we have to go for recycling process. But if you see the polythene carry bags, what will happen is the government made mandatory that minimum 120 micron thickness is required to do the plastic carry bags. Because once thickness is more easy for doing the recycling process. But the drawback, very well in plastics that plastics will have very long life. They cannot degrade. It takes minimum 500 years. But in the place of plastic polythene materials or polymer materials, I have gone for biopolymers so that they will undergo degradation in the environment condition so that it will be easy for us the recycling process, or you can give an alternate solution in the place of polythene carry bag. So if you see the basic difference between plastic, degradable and compostable. Any material it is non-degradable, degradable. Once it is degraded, if it is converting into compost. Out of all these things, right side most is always the best, because any material degrading into compost means it will be useful. It does not harm anything to soil. So that's why we try to go for compostable materials to make the polythene carry bag. So if you see the basically what are the biomaterials available, if you see this, there are so many materials available like PET bottles, polyadipate materials like this. These are all bioplastics. But bioplastics again, compared to polyethylene, polypropylene, PET bottles, biopolymers, they have one disadvantage. They will have slightly lower strength compared to compared to generally available plastic materials. That's why we have to judiciously take a call that where I should not have very, very poor strength, where I should not have high degradability and all the issues, but if it doesn't have strength, then it will be a problem. That is where I have done a lot of literature survey to see the biopolymers which are best for carrying the weight as well as it should degrade. So the first best option is polylactic acid. This is one of the biopolymer. It has very good strength, but elongation is only 4%. Impact strength is good, everything is good. But the problem is that it has high cost. It is, if you take it approximately 400 rupees per kilo, it will be there. See, polythene bag will come only for us here in our market, 120 rupees per kilo. If I sell any product 400 rupees per kilo, nobody will purchase. That's why this is I have taken, which is not a correct material for our application of making the carry bag. Second option I have gone starch. This is one of the best material. We found that we are taking the cornstarch. From the cornstarch, we are making the material so that it will be useful. At the same time, cornstarch will undergo degradation in a natural ambient condition. Second is that third one is cellulose. There is the one difference between cellulose and cornstarch. Cellulose cannot be digested to humans. It can be digested by only animals. Whereas cornstarch, it is digestible to human as well as digestible to the animals also. That's why instead of cellulose, we have taken cornstarch as one of the best material. Other two materials I have seen like polycaprolactam, polybutylene succinate. These two materials, they are very good in biopolymerity, but they can sustain only plus 60 degrees to minus 60 degrees. It cannot go to high temperature up to 80 degrees or 100 degrees. That's why these two materials I have not selected for our application. So finally, I have selected polybutylene adipate terephthalate, PBAT. This is basically extracted from the petroleum byproducts only, but is a 100% biopolymer material. So these biopolymer material is containing very good elongation and considerable strength compared to polylactic acid. But cost is low compared to polylactic acid. That's why this we have selected as one of the material for making the carry bag. See, now my focus is first I have to make a carry bag, because if you see the entire pollution in our country, the first best pollution, more pollution here happening at a carry bag. Second is water bottle. My idea is that first I have to replace it with the carry bags, then subsequently water bottles. So for that, this is my design of the product. I made it. The material should be replacement for the single-use plastic of carry bag. It should be eco-friendly. Should not have given any harm. It should not contain any plastic. No harm to animals and aquatic life, even it is thrown in water or soil. It should be degradable with bacteria, and good strength should be there, good elongation should be there, and it should be printable many colors, and it should be finally the cost effective. These are the design parameters to make the product. I made it. Then one by one we try to go for that. So whenever we do any solution, first what is existing solution we have to see. If you see the existing solution is polyethylene. Polyethylene, lot of problems are there. 200 years life, 300 years life. Domestically, it is causing lot of problem. It is not degradable. It is not converted into compost. And it is not converted into a lot of pollution is generated. PLA based thing, a lot of cost is there. There is one solution is there in the market that is called oxo-degradable. For plastic, you are adding some chemical. That chemical makes the plastic into small microparticles. These microparticles will fly in the air and it will cause a lot of air pollution and it will damage it. That's why my solution, whatever I'm going to be, it should be definitely out of these three, it should be the best one. That's why I've selected the crucial parameters of the material by taking this composition of selection of raw material. You know very well as an engineer, whenever you want to make a product, first I have to design parameter, I have to select it. Then the material I have to select it. After that, I have to go for design process, right? So, hope everybody is listening. Hello? Hello, is it audible? In between any break is there?
No, sir.
Yes, sir, we are able to listen.
Yes, sir. It's clear.
Any product, when we design, initially we have to go for design product that is completed. Now I have to select the raw materials. I have explored all the materials, whatever I said just now. Finally, I came to the combination of these four. One is PBAT, polymethylene adipate terephthalate. Another is cornstarch, some plasticizers and fillers to improve the strength and all the things. Why these materials only I have selected is PBAT is low cost, as well as it has the very good elongation, as well as good compatibility for strength. Second is starch. You know very well, olden days when I am in childhood, my mother is making rotis. If you see that powder, if you keep it outside, after 1 week, some insects will come in the powder. Why it is happening? It absorbs the external moisture, hence bacteria will generate, then insects will start in that powder generation. Means it started undergoing degradation. Same thought came in my mind. So this biopolymer PBAT has to undergo degradation, means I have to add some bacterial agent. That bacterial agent is nothing but this cornstarch, so that it will convert into compost. So like that, we made so many number of trials. Finally, we have come to a solution that this solution is workable, so that I am able to go for making the product. Okay, first I made some films to make the carry bag. So the laboratory level, you can mix the material solution and put on a glass metal sheet and pour it. Then after that, make in the form of film. Those films I made it and studied. Finally, I got it is very good degradable because of the cornstarch presence that is having the thing. So it is degraded. These laboratory tests are completed. But whenever any material we make laboratory level, it is not sufficient. We have to go industrial level, right? So same combination I have taken to make as in the form of granules. These granules basically I want to make it a large quantity production of the film. For that we have taken a twin screw extruder. You see there in the top I am mixing with the cornstarch, PBAT biopolymer and additives I am mixing. This is a high speed twin screw extruder where it will be melted, heated, and it will come in the form of wire in the form of extrusion. It will be dried. At the end, pelletizer will make it small pellets in the form of the granules. This is the first process. We made it in the form of granules. Once I make the granules, I have to make the film. To make the film, we are going for blow process. The blowing process is nothing but we are taking those granules and pouring in this machine. It will generate, blow the air from the bottom. It will generate in the form of film in the cylindrical form. This cylindrical form thing will happen Nothing but the film is blowing in the form of cylindrical fashion. It is the diameter is D. This diameter is nothing but your width of the bag. We are rolling that and taking in the form of the roll. Once we have done the rolling process, on the top of that we have to do printing. So it is a printing process. So we are getting the printing and design, whatever may be the thing, like a normal printer where we can have the ink and send this roller, the film roll in this, and you can get whatever the fashion of the prints. Now, after getting the thing everywhere, every stage we have done the quality control and quality assurance. At raw material level, we have tested moisture content, viscosity, ash content, density, melt flow index. In process parameter, we have done it. And final product, whether the bag is having good strength, elongation or not, thickness is uniform or not. All these parameters we have done at laboratory level testing and found that finally the quality is okay. These are the quality parameters we done on various raw materials and products. Okay. Once we made the product, we should test that whether it will convert into compost or not, right? For that, this IS 17088 standard says that how a material will degrade and what is the composition it has using DSC, FTIR analysis we have done. What is the carbon, hydrogen, nitrogen, sulfur, oxygen analysis to check the pollution and all the things. So these are the test reports. We have done it at SIPET Aurangabad, and we come to know that this product basically it has a conversion into finally 96% into compost. If you see this figure, you can easily understand. Take the film, tear into small pieces of that. This is the small pieces. After 90 to 120 days, it will become into microparticles like this. These microparticles are coming because of the bacterial attack on the film. This is the microparticles are generated. This is called biodegradation process. These microparticles, if I put on the plants, if the plants are growing without any harm, then it is called compost. Then it is called as compostable material. Our product is compostable material, which can convert out of 100% into 96% into compost. Remaining 4% is not compostable. Now, to make this, these are the equipments are required. To make the granules, you need extruder, blowing equipment, printer, and the equipment cost approximately 1.5 crore. Only you want to make the bags means only blow equipment and printer cost approximately 30 lakhs. Quality lab approximately 6 lakhs. Now the challenge in this technology, very well. Suppose if I make a equipment which is very other type of equipment to make this film and a bag, nobody will come. That's why I made a formulation in such a way that existing polyethylene making production equipment itself can be used to make this biodegradable carry bags. So that MSMEs and all the polythene production industry can shift to biodegradable bag making industry. That is the reason, that is one of the main challenge I faced when I am converting the existing mission into biodegradable bag making mission, where that is the main crux it has happened for me. So any product, once you design, the cost is the main important thing, Biodegradable bag, if I take it per kilo, it will be approximately, it will be around 140 rupees per kilo. Whereas polythene, if you take approximately per kilo, approximately it will be 120 rupees. Compared to biodegradable bags, polythene bags are 20 rupees cheaper. But one advantage you will get is that polythene, suppose I want to carry 2 kg weight. Generally what will happen, and polyethylene I need 60 microns thickness. But as per the government rule, they made it more than 120 micron thickness, you have to make it. But in biodegradable bag, there is no thickness limitation. Hence, in polythene, per kilo, if you get 80 pieces per kilo, in biodegradable, you will get 100 pieces per kilo. Hence, 20 rupees more will be balanced here. Now, very well for naval applications, this is water resistant carry bags we made for domestic applications. For Navy, Indian Navy, very well, they will go 6 months into the deck. They will carry all the stuff when they go. After eating, they will throw all carry bag in the sea water. Again, it will come to shore of the thing. Hence, I made a carry bag which is water soluble. Once they eat it, if they throw in sea water, it will dissolve in water and does not harm because it is made by another formula of polyvinyl alcohol. So finally, once you make the product, what you have to see? You made an excellent design and product, but it has to send it to market. We thought of that where we can start launching of this product. We went Tirumal Tirupati Devasthanam, maybe knowing everybody Tirupati, where after darshan you will go to Laddu purchase counter. If you go there, you will see one counter, DRDO counter is there. There we have launched first time in Tirumal Tirupati Devasthanam. If you go now also, you can see once you take the Laddu, you can see the carry bag. It will be there on that DRDO logo, which is my product, which is distributed there. So you know very well, once the product has done the design, you may get some feedback, whether it is good or bad, right? So we are given to pilgrims our phone number and we asked after going home, tell me what is the any issues are there. We got some calls calling back that sometime when we are carrying, the handle is breaking. Because you know very well, generally a bag designed for 5 laddus, but that fellow, he will fill with 10 laddus. Means 50% factor of safety we had to give. So since we thought of that initially, each carry bag, they may carry 4 laddus or 5 laddus. That's why that is not catered. Once we got this suggestion, we are given double factor of safety. Now they told it is excellent. That's why once you any product you have given to market, you have to see that feedback, whether it is good or bad, any problems are there. We have to do some modifications and all the things. That replacement and modification continuously we have done now. Finally, we have succeeded and we made this carry bag and all the things. This is where we have launched the carry bag at Tirumal Tirupati Devasthanam by our secretary DRDO, Dr. Satish Reddy, and my team, everybody, we are there here. In this Pride movement, you can see this. Then after that, you know, it has gone into publicity into many fields, so that many media, so that we are given to this technology on free of cost to industry. Technology and formula were given free of cost to industry. And this technology has been given the notice by the Niti Aayog to implement in all government offices and all the things. That is where we have succeeded very nicely. And we gave technology transfer to many people, industry. Now across the India, 45 companies are doing this production in huge quantity. And we are given even this technology transfer abroad also, US, Rwanda, African countries, Dubai and all the places we are given this technology transfer. So after that, for this innovation, I have been awarded Navanakshatra Sanmanam in 2022 in Science and Technology category by seeing this product which will be compostable, which is one of the best replacement for polythene carry bags. Nowadays, you may be seeing in your Vijeta mall or some mall, if you go, you can easily see all my products. My product you can see in all the stores and shops. Where it is biodegradable bag is there, means that is my product only. That is my innovation only. To make this product to go to market, we made one documentary. Anybody wants to see entire technology connected thing, you type in YouTube Dr. K. Veerabrahmam DRDO, you will get lot of volumes of information where I have given some more details of technology, what is happening across the world, what way our technology is better and all the things. For that documentary also we got Best Documentary Award for that. And after that, this is Golden Peacock Eco Innovation Award in Bangalore and Environment Excellence Awards and all the things just now already Dr. Rashid told anyhow. Now we are giving this technology transfer on free of cost. Even we are not charging royalty also. Because this is useful to environment. That's why we thought of DRDO, I thought of that we'll give this technology on free of cost to industries. So that industries can be benefited. At the same time, we can save the nature. That's the final thing. With this, we got a lot of future projects for making the bottles, cups, straws, and all the things. We have had some milk packets and all the things. A lot of projects I got after this for replacement of this. Finally, I would like to thank the person who are behind me, who has done a lot of support to me to make this realization of this product as a substitute to polythene bag. That is our Chairman, Secretary DRDO, our Director and my friend Dr. M. Padmanabharazu, my colleague Dr. N. Ranjana and everybody. Definitely as a team, I may be the team leader and I've done many of the things, but without their support, I would have not been done this much successful. Thank you very much for giving this opportunity and thank you.
So, thank you very much, sir, for such an insightful and enriching session, sir. Because our topic was, sir, smart and sustainable manufacturing. So, previous speaker have talked about different smart manufacturing processes, sir. For your lectures, it reminds us what is the sustainability. Even if you make many manufacturing products smartly, but that need to be sustainable. Otherwise, there is no. Nowadays, we are seeing many climate changes are there. Global warming is there. Many issues are coming.
Correct.
So I hope for students, our faculty,
now government also a lot of initiations have been taken to go for making the products which are eco-friendly and sustainable products. That's why I think many of you can start working on this so that it will be most advantage to nature as well as for you also.
Yes, sir. So now we'll open the floor for question. Participants, any query, any?
Yeah, no problem. No problem.
Yes, sir. Good evening, sir. Or you can.
Yeah. Good evening, sir, Dr. Veerabhadra, sir. I am Dr. Ramesh here.
Nice, sir. Please.
Associated with the Department of Mechanical Engineering, Nalla Reddy Engineering College, sir.
Oh, nice.
I have attended your session in MSME program also.
Yeah.
IPR.
Okay,
program
yes.
And one important question which I have in my mind is I purchased one of this cover from More Supermarket in one of the location.
Okay.
But when we take that vegetables and all in that particular, since it is actually biodegradable and it can degrade by itself, suppose if we put anything like lemon or some other element, actually lemon will get dried out and it will become brown in color after a few days. But in this case, in this cover, it is totally changes in color in the next day itself with green marks on the outer spots. So some of the food materials, I think it gets contaminates with the food. I think so. I'm not sure about that. Maybe is it possible in some cases or it is not suitable for those materials like that, sir? I'm just getting.
Yeah, very good question. Actually, first of all, you see, this is the carry bag meant for bring something, and after bringing something, you have to just crush it, you have to throw in dustbin. Basically, this is a single use product. Okay. Suppose generally what will happen, some people they will use after bring back also, they will use again one more time also, there is no problem. If it touches with any solid, nothing will happen. Even with lemon also, lemon property does not lose. Only one thing is that this product we should not use for hot liquids. We are not suggesting them to use for hot liquids, but remaining all the things you can carry, there is no problem, nothing will happen. But generally, you know very well, polythene will have more water resistance property compared to biodegradable materials. That's why in fridge, if you put this material also, nothing will happen. But 1 week, 10 days after that, you have to throw it out. Other cases, you can store it outside, nothing will happen. And it does not contaminate any of the material. But only thing is, you should not have hot liquids. Liquid carrying and hot liquids, we are not suggesting, basically.
My thinking and suggestion is that since it is self-degradable, when we put the laddu directly inside,
yes,
there may be a chance it may influence that food material directly into contact.
No.
If it is not in contact, then it's not a
problem. Materials, nothing will happen.
Okay. Okay.
Because you don't have any contaminating material in that.
Okay. Thank you.
Any question from participant side? Yes, any question from participant side, you can ask to sir. Sir, I have one question.
Yeah, please.
Sir, we have existing processing infrastructure for polythene bags, sir. So
Okay.
how that processing infrastructure can be adapted for biodegradable polymers, sir, or any other biodegradable material?
No, no. Processing existing?
Existing our infrastructure, processing infrastructure.
Yeah,
Suppose
yeah.
we are
Production
using- Yes,
infrastructure. Yeah,
sir,
right.
production.
See, generally, blow equipment will be there to make these carry bags. Okay.
Okay, okay.
That blow equipment, what will happen is in that existing blow equipment, you will have the temperature control up to 100 degrees.
Yes, sir.
Here we may use 120 to 140 degrees temperature to make this bio-based carry bag, number one. Second thing is in the existing equipment, polythene making bags, you don't have rotating die.
Yes.
But here you need rotating die to make uniformity in thickness of the carry bag.
Okay.
So second thing is in polythene, you can go higher speed production. Here we should have slightly lower speed production you have to go because polythene will have more elongation, it cannot break. While production time, this will have slightly less elongation compared to polythene. Hence it will break easily if you go high speed. That's why polythene bags, if you make 500 kg per hour, this you can make only 400 kg per hour. So these are all modifications we have done for the existing mission of the polythene making bag making machine. So that is one of the advantage we got it. Suppose if I put suddenly new machinery and everything to make the bag,
Yes, sir.
all current bag making people may not shift to this industry.
Yes, sir.
So my idea when I am designing the product itself, I thought of that type of elongation I should give to them so that in the same machine we can make it. For that we are adding some plasticizer in that.
Okay.
That is the reason only we are adding some little plasticizer. So that cannot affect your machine while it is going production time. The flow will be continued.
Yes, sir. Thank you, sir. So one more question about that cost, sir. Of course, biodegradable bag will be the cost will be more, sir. How we can minimize, sir, compared to that polythene bags, sir? Polythene bags are very cheap, so that is also one factor, sir.
That's what I'm saying. Basically, you know very well, virgin polythene bag making material will be 120 rupees per kilo to 140 rupees per kilo.
Yes, sir.
But generally, what these guys are doing at outside is, whatever the thrown carry bags or other plastic products they are taking and recycling, and again they are selling for 70 rupees, 80 rupees.
Yes, sir.
Actually, polyethylene itself is very dangerous. Again, recycled polythene is double danger.
Yes, sir.
Many of these people does not know. Example, you take any market, people will go. Their pav kilo one vegetable, other pav kilo one vegetable, like that 5, 6 small carry bags they'll put in again one big carry bag and they'll carry.
Yes, sir.
Actually, that is the reason we told to government that you ban all the polythene bags.
Okay.
That is the reason you see recently we have given our recommendation letter to AP government. They have banned the plastic completely.
Okay.
So because there's a very, very danger. Basically, plastic is high danger compared to, especially carry bag and water bottles are highly dangerous.
Yes, sir. Because of that,
This should come from enforcement agency like Pollution Control Board.
Yes,
and
sir.
At most, finally, I can say that personal discipline is very, very important.
Right, sir. That is the most important.
We should avoid it, maximum. Suppose I go market, at least take one carry bag instead of 10 carry bags.
Yes, sir.
That will be always better so that we can save environment.
That's it. Participants, any questions from your side you can ask. No questions from
I think no questions.
no questions, sir.
Yeah.
Okay, sir. Thank you once again, sir, for your valuable time and delivering this wonderful lecture, sir.
Opportunity. And at the same time, I wish you all the best for your online conference. Okay.
Thank you, sir.
Thank you very much. Thank you.
Thank you, sir.
All right.